Hello and welcome. My name is Dr. Garrett Ashbrainer with the University of Georgia Poultry Science Department. In today's presentation, I'm going to be talking about my doctoral research, where we looked into giving broiler chicks dark periods from day of placement. And so in today's presentation, I'm going to be trying to tell a little bit of a story. I'm going to start of where we started with this research, and then the progression of it, and then where we ended up with this research. And to start off, kind of comes down to how I got to University of Georgia. So I was a broiler farm manager back in Texas, and I had the opportunity to go to grad school at University of Georgia Poultry Science Department. And so when I arrived at UGA, I was working under Michael Zarek and Brian Fairchild, and they gave me a lot of autonomy. They told me to go out in the field, dig into the literature, and try to find, um, a novel project to do your dissertation on. And so somewhere around that time, we were sitting around a conference room table, and we were talking about presentations and looking at graphs and stuff. And we came across this graph. And so this is hourly water usage over 18 different chicken houses across 8 farms. And so historically, with mechanical water meters that aren't quite as sensitive, we haven't been able to detect the low flow water usage from chicks at placement. We have pretty novel ultrasonic water meters now that are very sensitive, and that we can start detecting water usage, around 30 minutes after chicks are placed. And looking at this, so what we see here is hourly water usage on the vertical axis, and we have day of age on the horizontal axis. And what we see here is after placement, we see a pattern in water usage where it goes up during the day, down at night, up during the day, and down at night, up during the day, and down at night again. And so if we look into it a little bit further, when we get past 5 days, that pattern kind of dissipates. But it got me to thinking. So we see these natural patterns in water usage after the birds hatch, even though we're giving them 24 hours of light. And so that got me to thinking of circadian rhythms, those rhythms that all life on Earth exhibit, that are based off a 24-hour period. Whether you're a bacteria, a plant, a chicken, or even a human, you're influenced by circadian rhythms. And so, thinking of it a little bit more, light is the greatest influencer of circadian rhythms. The light dark cycles of the sun, or artificial light too, are what kind of get circadian rhythms going. They're the greatest influencers, and we see these patterns. We see these day and night patterns in chicks' water usage, and we can associate that with a little bit of behavioral patterns, even though we're giving chicks 24 hours of light. And so it kind of got me to thinking that why actually do we give chicks 24 hours of light during brooding, or at least near continuous light? That when you start talking to people, it's kind of assumed that chicks will eat more feed, or some people think it's kind of a remnant of older times when we had our older chicken houses that weren't quite as tight, that it was a little bit harder to completely control the environment. But we gave chicks 24 hours of light, so chicks wouldn't get caught in a cold spot within the chicken house when the lights turned off. But it kind of got me into a mood to read about lighting programs, and really diving into the literature, really digging into the lighting literature to see where the evidence for continuous lighting during brooding comes from. And when you actually get really deep into the literature, there is essentially no research or at least there was no research when I started this project to sit there and show that um, giving continuous or near continuous light during brooding was an effective practice. That there was no evidence that it made them eat more feed or anything like that. We have these standard practices of giving them continuous light or near continuous light, from anywhere between 3 to 7 days, or maybe some brooding periods go a little bit longer. But still, we can say we give almost 24 hours of light during brooding. And what I've actually found was fascinating, that when you look into the old poultry books, people have been debating giving chicks 24 hours of light during brooding, since the early 1900s. So that being said, that led to a series of studies that I ended up turning into my doctoral dissertation. It was a series of 12 individual trials that ended up composing of 4 different studies, looking at either 4 or 6 hours of darkness at varying flock lengths, and then we finished it out looking at this in a commercial broiler flock. So kind of, our general objectives, that we really just wanted to see what happened to chicks if we gave them 6 or 4 hour dark periods during the first week of age. And we raised some of these birds to 14 days, some of them to 21 days, and some of them to 42 days, depending on the study. So it was really, we just wanted to see, how birds responded to the dark period during brooding. And so, to give you a little bit of an idea of how we designed this experiment for our control birds, what we did is we gave them 24 hours of light for the first 7 days. And the night of the day 7, we in study 1, we gave them 4 hours of darkness. And then we kept that, 4 hours of dark, 4 hours of light from days 7 to 14. For our treatment birds, what we did is we gave them the 4 hours of darkness, 20 hours of light from day 0, day of placement, to day 14. We set them up into different rooms. So there were 6 total rooms. 3 were set to treatment, 3 were set to control. We had multiple pins per room to be able to study this. And if you're looking at what our experimental unit was, room is our experimental unit. So the data that we collected for this, our performance was going to be body weights and feed conversion ratio, and we were able to track that at days 0, 3, 7, 10, and 14. We also took blood samples. So we did corticosterone, which that's the stress hormone in birds. So we wanted to see if either of these lighting programs, exhibited a stress response to the birds. We also looked at melatonin. So melatonin is that hormone that is highly associated with sleep. It's associated with circadian rhythms. It's associated with oxidative stress. It's associated with regulation of almost every part of the body, because it ties into the circadian rhythm. And we took blood samples on days 6 and 13. So that was the day before the days we weighed the birds. And we took blood samples then to, so our picking up and weighing of the birds didn't influence any of the blood samples. So getting into the actual data that we see, so I'll kind of go over how my graphs are labeled here. We'll see some type of performance parameter on the vertical axis. We'll normally see day of age on the horizontal axis. The yellow lines will always indicate the control birds, and the gray lines will always indicate the treatment birds. If our p-value here has a little asterisk, that means it's statistically significant, and my vertical black bar indicates the day when the control birds received their first dark period. And so looking at body weight from day 0 to 14 in the first study, so remember this is an average over 3 individual trials. What we see here is day 1, there are no differences in body weight, so we were able to evenly distribute body weights in our pens. But day 3, we actually see a significant difference. and with the control birds weighing significantly more on day 3. And that continued to day 7. So by day 7, the control birds that were given 24 hours of light ended up weighing more. And that was I was a little bit concerned about that because we were hoping that we would see the opposite. But something very interesting happened that after the control birds were given their first dark period, and when we weighed the birds on day 10, we actually see the opposite happening, where the treatment birds weigh significantly more than the control birds. So kind of exhibiting some type of what we would call compensatory growth. And by day 14, there seems to be a numerical difference, what we might call a trend here in the treatment birds weighing more, but when you look at it statistically, there was no statistical difference, that they weighed the same. So looking at feed conversion ratio from days 3 to 14, what we see is that there are no differences in feed conversion ratio between treatment and control, whether it's before or after the dark period. So that's a pretty good sign so far. Looking at corticosterone, so what we see is corticosterone that we observe during the dark period here is that we see the night of day 6, we actually see a significant difference between light and the treatment and control. Although on the night period of day 13, we did not see a difference. When we look at the daytime corticosterone, we see no differences in day 6 or 13 comparing treatment and control. And so we do see this significant difference, higher corticosterone levels in the treatment birds on day 6, and unfortunately that was one of the first times some of our members of our lab were taking blood samples, and we have a feeling that it's one of those things that sampling error ended up coming into this, and this may not necessarily exhibit a stress response, but it may just be sampling error. But when we get into the melatonin, so remember melatonin is that hormone associated with sleep. When we look at dark period melatonin, we see on day 6 and 13 during the dark period, the treatment birds had significantly higher melatonin levels. And when we look at the light periods, we still see that significantly higher melatonin levels during the day 6 and 13, even during the light period. And so I want to draw our attention to day 13, that remember that by day 13, those birds had been on the same lighting program for 7 days. The control birds had not caught up in melatonin production, even after 6 or 7 days of being on the same lighting program. We find that very interesting. So we ended up wanting to continue this research, try to add a few more things into it. So we decided to take it out a little bit longer, and we wanted to see if giving 6 hours of darkness exhibited the similar responses. So we have control birds that, again, for the first 7 days, they're given 24 hours of light. But from days 7 to 21, they're given 6 hours of darkness, 18 hours of light. On our treatment birds, we see 6 hours of darkness, 18 hours of light, from day 0 to 21. So the performance we collected, it's going to be the same: body weights and feed conversion ratio, and looking at 0, 3, 7, 10, and 14 and 21 days of age. We did the same blood samples, corticosterone and melatonin, but we also added an additional measure of what we would call superoxide dismutase. And it is an antioxidant of the body, and it's an indicator of oxidative stress. Superoxide dismutase has been associated with melatonin, as well as light and dark periods. Improper lighting programs tend to elevate oxidative stress. So we wanted to, potentially tie this in, see if there was any effect to oxidative stress. And we took these samples on 6, 13, and 20 days of age. So for our body weights from day 0 to 21, we're going to see a very similar trend to our previous study, that day 0, no differences. Day 3, the control birds had higher body weight. Day 7, the control birds had higher body weight. But once those control birds were put on the same lighting program, we actually see no differences between treatment and control on days 10, 14, and 21. So very interesting material here. When we look at Phe conversion ratio, we see again a very similar trend here to our previous study, is that there are no differences between treatment and control for our Phe conversion ratio either before or after we give them a dark period. Our corticosterone, we see actually no differences between treatment or control between day 6, 13, or 21, either during the dark period or the light period. For our superoxide dismutase, so that oxidative stress measure, is that we see no differences in that either. When we start to look at melatonin during the light and the dark period, we see some very interesting trends again, that we see higher melatonin levels in the treatment birds on days 6, 13, 21 during the dark period, as well as during the light period. So I want to remind everybody and draw everybody's attention. Days 13 and 21. So that's 2 weeks of the control birds being on the same lighting program. That the control birds still haven't caught up significantly in their melatonin production. So really interesting stuff. So we decided to carry this out longer. So we've realized, okay, the 4 hour dark periods are showing some interesting results. The 6 hours of dark period are showing interesting results up to day 21. We wanted to see what it did to day 42. So for our control birds from day 0 to 7, we gave them 24 hours of light. From day 7 to 42, we gave them 6 hours of darkness, 18 hours of light. For our treatment birds, we gave them 6 hours of darkness, 18 hours of light from day 0 to 42. So for the data that we collected, our performance, our body weights, and our FCR, we did the same stuff, and we did it weekly up to day 42. For our blood samples, we're looking at the same stuff, corticosterone, melatonin, superoxide dismutase. Again, looking at it weekly, but we also added a leg health aspect. So we looked at bone breaking strength and gait scores, and we collected that data on day 42, so the last day of the trial. So looking at body weight from day 0 to 42, we see again is a very similar trend to what we have been seeing in the past 2 studies, that day 0, no differences. Day 3 and day 7, we see higher body weights in the control groups. Day 10, no differences. But interestingly, on day 14 and 21, we actually see a significantly higher body weight in the treatment birds. But days 20, 28, 35, and 42, we see no significant differences in body weight comparing treatment and control. When it comes to Phe conversion ratio, again, we're seeing a very similar trend. There's no differences in FCR between treatment and control, giving them the 6 hours of darkness. When it comes to gait scores and bone breaking strength, we actually didn't see any differences in it. So we're probably going to associate that with birds being raised in very controlled experimental research conditions, and we might see a little bit some differences out in the field, but this kind of indicates that neither of the lighting programs are significantly affecting leg health through gait scores and bone strength. Now, when it comes to corticosterone, we again see the same trend as before. We see no significant differences between treatment and control. Again, superoxide dismutase, no significant differences here. But when it comes to melatonin, in this particular graph, we're looking at melatonin during the dark period. We see significantly higher melatonin in our treatment birds on days 6, 13, 21, 27, 34. It wasn't until day 41 until the control birds caught up in their melatonin production. And remember, that's 1, 2, 3, 4 weeks of those control birds being on the same lighting program as a treatment before they were able to catch up in melatonin production during the nighttime. So when we look at the light period melatonin, what we see is, day 6, 13, 20, and 27, significantly higher melatonin production in the treatment birds, but it didn't, on 35 and 41, we see no significant differences. So again, it took 1 to 3 weeks for melatonin production to reach something similar for the control birds to the treatment birds during the light periods. So again, really fascinating material here. So to try to give you a little bit of a summary of what we've seen is that the control bird's body weight and feed consumption were higher during the first week of age, but by the end of the study, over the 3 studies we've done so far, we saw no significant differences by the end of the flock. Feed conversion was unaffected by these lighting treatments. There was no differences in mortality, and overall, the performance was unaffected by either of the lighting programs. So when we look at the blood assay summaries, again, no difference in corticosterone. So, trying to extrapolate that. So neither of these lighting treatments causes significant stress response as measured through corticosterone. And we didn't see any differences in superoxide dismutase. So, indicating that neither of these lighting programs significantly elevated the oxidative stress as a measure of superoxide dismutase. But what we do see is very interesting is that the treatment birds had consistently and significantly higher melatonin levels until day 35. And some people might ask, did we change the circadian rhythm of the birds? And we probably didn't really see a change in circadian rhythms. That the fold difference, the percent difference between light and dark periods comparing control and treatment birds was relatively similar. The fold difference between night and day isn't that different. But we do see is that the melatonin set point has changed. And like I said, melatonin is associated with circadian rhythms. It's associated with regulation of many aspects of physiology that it's tied into the circadian rhythms. And remember, it is the first line of defense of the oxidative stress in the body, and it is again associated with sleep. So we could kind of extrapolate that having higher melatonin is probably better than having lower melatonin. So that led us into wanting to see what the response of birds to these lighting treatments are out in the field. So we utilized a 4-house broiler farm of over 3 flocks, comparing 24 hours of light versus 18 hours of light, 6 hours of darkness during brooding. We separated this by house, so each treatment, we basically an experimental unit of 4. And we collected weekly body weights, uniformity, and mortality. And so just to kind of give you a little bit of a summary of how we designed this, that the control birds from day 0 to 5 got 24 hours of light. The grower wanted to step up their dark period, so he gave them 4 hours of darkness, 20 hours of light from days 5 to 7. And from days 7 to 42, they were given 6 hours of darkness, 18 hours of light. And then the treatment birds were given 6 hours of darkness, 18 hours of light from days 0 to 42. And again, we separated this by chicken house, so there's approximately 28,000 birds in each of these houses, and we weighed approximately 100 birds per section weekly to see to get an idea of what the body weights were looking like. So when it came to body weight, what we see is there are no differences between treatment and control on any day of the flock. So when it comes to uniformity, so basically how close in body weight these birds were, we measure that through what we call CV. So we see no differences in uniformity in body weight comparing treatment and control across the flock. As for mortality, This was collected by the grower. We didn't see any significant differences in what we have here on day 28, 35, and 42. We see a very high mortality, and what we ended up having, the inclusion body hepatitis popped up in all three of the trials we did. But we found an interesting trend here. It was not significantly different, but we actually do see, kind of a trend in lower mortality. And we might see numerically a lower mortality in the treatment birds. So if we extrapolated this over, many more chicken farms, many more, chicken houses, we might actually see a significant difference. But with the experimental size we had, we just didn't see that difference. But definitely an interesting trend we see. So one other thing we did is we went through the chicken house, and this diagram here represents the chicken house. The blue lines water line, the red lines are feed lines, and me and some of my students, we'd walk really slowly down one side of the chicken house and then circle back and walk up the chicken house and back around, and we tallied up the birds we saw that were culls, that were mostly associated with some type of leg issue. Okay, was it exhibiting, trouble walking, basically higher, gait scores and such. And we would tally that as we went down the chicken house. And what we see here, so average count for the control birds was 119 per house, and average for the treatment was 86 per house. And when we look at that as a percentage, that's 0.49 and 0.34. So this was not statistically different, but we might see a trend in lower cull counts in our treatment birds. So again, if we maybe extrapolated this over maybe an entire complex, utilizing many more chicken farms, many more chicken houses, we might actually see a significant difference. But with the design we had, we did not see any statistical differences. But again, very interesting observations, very interesting data we were able to collect. So overall, our field trial summaries is that overall the performance was unaffected by the lighting program. So, I can get into it a little bit later. That actually, is probably a good thing. So when we look into the conclusions of this, and kind of like our take-home message, is that providing chicks with a dark period during brooding doesn't significantly affect body weight, feed consumption, or feed conversion ratio by the end of the flock. And, when we're thinking about this, some scientists really like to see, significant differences. They like to see, they want that significant difference. It's a failure if it's not significantly different. But when it comes to this kind of stuff, actually, a significant difference is no significant difference is good. That means that we can implement a dark period during brooding without affecting performance. And this is something that can be implemented on pretty much any farm without any cost to the grower. So some of our other conclusions that are maybe tied back into the welfare is that, providing dark periods during brooding adds a welfare component without affecting performance. And I know we didn't see a significant difference in corticosterone, but my rationale for this statement is that light and dark periods have been shown to affect welfare. That's again and again why we can see the dark periods and light periods and how we manipulate them have an effect on welfare. And of the 5 freedoms of animal welfare, the 5th freedom is the freedom to express natural behavior. And I would vouch to say that sleep is a natural behavior. And, it's one of those things that, as agricultural specialists, I really think we have to step back and think that, our job ends up coming down to, we are having to grow food for an ever increasing population. But we have to balance animal performance with animal welfare. And I see this as one of those solutions that does balance that tightrope between animal welfare, providing a dark period during brooding, without affecting performance. And I feel that's the way that we should go into the future, is that finding those welfare solutions that have some type of response to welfare that aren't negatively affecting performance. So with that, I appreciate your time listening to my presentation today. If you have any questions, please reach out. If you have any ideas for future presentations or webinars, please, again, reach out and let us know. With that, I appreciate your time. We'll talk to you later. Goodbye.